Good morning, everyone. In the last session, we had discussed the different types of DC-DC converters and their modes of operation. Now, let's discuss the effective variation of inductor value on the modes of operation of a boost converter. So, as we all know, any DC-DC converter, whether it's buck boost or buck boost or any other derived converters, they operate either in CCM, that is continuous conduction mode, and DCM, that is discontinuous conduction mode. So there is also a critical conduction mode in between this DCM and CCM. So in CCM, the input inductor current will be continuous, and in DCM it will be discontinuous. Okay, so in critical conduction mode, the input current will just touch the zero once in each period. Okay, so also we had discussed in the last session what are the advantages and disadvantages of each of these modes over the other one. Okay, so now let's discuss the effect of variation of inductor value on the mode of operation. So the figure shows a simulation model of a boost converter in PC. Now we can vary the inductor value like this. So this is the input box. Let's give a value 1 millihenry for the inductor, and let's simulate it and see the variation of input inductor current with respect to the gating pulse. So I1 represents the input inductor current and V1 is the gating pulse. So this is a simulation result. Let's see the waveforms for a shorter period of time. So this is the waveforms. So see the values here. The blue one shows the gating pulse and the red signal is the input inductor current variation. Now here from the figure it is clear that the input inductor current it increases during the turn on time, then during turn off time it decreases to 0, then its value is 0 for the rest of the turn off time period. That is, here the boost converter operates in discontinuous conduction mode. Okay, so that is it. Now let's change the value of input inductor. uh, let's give the value, the designed value, that is 6 millihenry. So see the difference. Simulate this. Let's see the variation. So this is the waveform. Here, as we can see, the input inductor current, it just touches the 0 once at the end of the turn off period, then it again increases, then at the starting of turn off period it decreases, at the end of the turn off period it reaches the 0 value, again it increases. That is, here the boost converter operates in critical conduction mode. Okay, so again let's change the value of the inductor. Let's give some higher value, say 10 millihenry. So again let's simulate the model, input inductor current, gating pulse. So this is the waveform. Let's study this. So this is the waveform. Here we can see the input inductor current, it is well above from the 0 line. That is, here the boost converter operates in continuous conduction mode. Okay, see the difference, that is the effect of variation of this inductor value. With the value as designed value, the boost converter operates in critical conduction mode, and below the designed value it operates in discontinuous conduction mode, and above the critical value it operates in continuous conduction mode. Thank you.